Ladies and gentlemen, thank you for your kind interest into this article and welcome to this audio slide presentation. I am Amir Hossein Haqi, and in this presentation I will give you a summary about our paper entitled A Case Study for HCL-based Fracturing and Stress Determination and Deformation Diffusion Thermal Approach, accepted by Journal of Petroleum Science and Engineering on 18 October 2013. HCL-based fracturing is a well stimulation method with hydrochloric acid that conductive fractures are created in the formation around the wellbore and reaches far into the formation. Fractures are created by applying pressure to the wellbore exceeding the fracturing pressure of the formation. Pressure is applied from the surface by pumping acid at a high rate into the rock matrix, accordingly creating a fracture by acid flow in an area around the well will effectively remove skin effect. As a result, hydrocarbon will bypass damage done through the fracture rather than crossing across rock pores. Therefore, the permeability near the borehole increase and consequently the well productivity index increase. To set up a complete deformation diffusion thermal solution for stress magnitude determination with acid fracturing phase at all, we applied the solution proposed by Kirsch regarding tangential stress distribution for vertical in a polar coordinate. For this approach, the DDT solution, we suppose two different models for fluid flowing fracturing corresponding stress equations, including radial flow and bilinear flow assumptions. For reopening process, bilinear flow equation is used. Accordingly, in this study, for the first time, a triple DDT full solution was introduced to estimate maximum horizontal stress magnitude by using rock mechanics and poroelastic equations for circular underground cavities, fluid diffusivity equations through Perth median thermal stress. In this approach, H function is introduced, which is related to the stress ratio. Furthermore, in this study, for the first time, semi-stress polygon is introduced that shows the range of allowable values for H function in the Earth's crust for normal slip and reverse faulting environments at the particular depths for a given pore pressure and assumed coefficient of friction. In this graph, the relation between H functions and depths is evaluated by using several worldwide case studies. HCL-based fracturing has implication in stress orientation measurement as well, as it is illustrated in the model. FMI boss caliper records deviation from bit size, and on the other hand, the dark parallel lines are thick lines which specify the direction of maximum horizontal stress. This graph verifies the sensitivity of DDT formulas with temperature in acid fracturing. To verify these formulas in this study, we have done a stress analysis using DDT approach and semi-stress polygons for field in Persian Gulf. H functions for field A in Persian Gulf predicts strict slip faulting environment for the region. Minimum and maximum horizontal stress for field A by DDT solution with assumption of bilinear flow in reopening cycle approximates equal to 7180 and 8730 psi respectively. In this study, an efficient methodology was presented to estimate the full field in situ stress on the basis of complete deformation diffusion thermal solution. This method improved weaknesses of other fracturing methods, including less breakdown pressure, by producing heat at the bottom hole, easily defined fractures with caliper and image logs for stress orientation, simulation reopening pressure with bilinear flow assumption instead of using inaccessible breakdown pressure in deep petroleum reservoirs, taking into account thermal stress effect in order to consider undeniable effect of heat production due to chemical reactions at the bottom hole, introducing a triple full solution for direct estimation of maximum horizontal stress. On the other hand, the minimum and maximum horizontal stresses are approximated by the DDT solution for a field in Persian Gulf, and simulated minimum horizontal stress adjusted greatly with the leak of pressure regarding to the calculated principal stress. Slip faulting environment is predicted for the field A in Persian Gulf. Thank you again for your kind attention.